Bismillahirrahmanirrahim. I am Dr. Muhammad Ishaq Jan, Assistant Professor in Department of Chemistry, Cohort, University of Science and Technology, Cohort. The topic of my presentation is synthesis of drug-mediated copper oxide nanoparticle capped with acetic acid for colorimetric sensing of oxalic acid. The layout of my presentation is an introduction. I will mainly focus on nanotechnology, as you people are much more familiar with the word nanotechnology, that it ranges those substances uh, which range from 1 to 100 nanometer, and due to its smaller particle, it has unique properties and it can also be used in medicine, energy, and electronics, and so on. Biosensor are those substances which can be used to detect the level of some molecule and copper oxide, which we have selected in this presentation, that it has so many properties, like it has tiny properties. They are smaller in size. It has high surface area and high reactivity, and it has also some antimicrobial and anti-cancer properties and so on. In this presentation, we have selected oxalic acid as an analyte molecule because the high level of this oxalic acid is dangerous in human body because it can precipitate in kidney in the form of calcium or iron oxalate and can cause kidney stone, and if it is not properly treated, it can also proceed to renal failure. In this study, we have actually synthesized copper oxide nanoparticle, and then we capped it with the acetic acid to increase its reactivity, and then we use these nanoparticles to sense the oxalic acid level, and we also use this platform and this biosensor to check the level of oxalic acid in human sample as well. We synthesize copper oxide nanoparticle from their respective salt, and for this purpose we dissolve paracetamol in DMSO, and then we use the filtrate of this paracetamol for further process and mix with their respective salt, and then we stir for the 4 hour, and then we centrifuge to collect the nanoparticle at the bottom, and then we wash these nanoparticle with water and ethanol, and then we dry it in an oven. For this purpose, to increase their reactivity, we mixed 1 ml of acetic acid with 6 milligram of copper oxide nanoparticle to make it capped and functionalized. For the initial reaction, we mixed 100 microliter of capped copper oxide with 100 microliter of oxalic acid, and we checked that the reaction occurred, and we can proceed. For this purpose, we can also check it with naked eye, and you can also see here that the color from light bluish to uh, transparent occurred. And we have also checked the absorbance of the color through UV visible spectroscopy, and we have checked that the absorbance has been reduced. This is the mechanism in which the copper oxide mixed with oxalic acid and make copper oxalate and lose and or reduce its color intensity. And then this reduction in the color intensity can be used for the quantification of oxalate or oxalic acid. We also assisted this assay through machine learning using red, blue, and green value were determined by using the Python imaging library, and then we use the RBG values for their and their correlation with the non-concentration of oxalic acid solution, and then we use different machine learning, and 4 different prediction model were selected, including random forest, linear regression, XBoost, and free regression. In the resultant discussion, first we have checked whether the reaction occurred or not. So you can see here that the reaction occurred when we add oxalic acid to this copper oxide. Absorbance has been reduced, which has been also investigated through visible spectrophotometer, and we can also uh, see here with the naked eye. This is the FTIR, and here in the peak, you can see here that at 50 cm inverse showed the peak here, uh, uh, showed here that the nanoparticle has been successfully synthesized. This is the XRD, and we have also calculated the size of the nanoparticle, which was 26.15 using Debye-Scherrer equation. This is the morphological uh, structure of the nanoparticle, and the same images show that they are sphere in their structure. This is the XPS analysis, and we have also optimized the sensor to sense the level of oxalic acid in context of various parameters like capping of acetic acid, pH, time, and oxalic acid concentration. This is the effect of capping, and you can see here that the 250 microliter capped of acetic acid with the nanoparticle produce good result. Here you can see that the best pH on which it is uh, functioning, that is 7, and the complete time it take to uh, complete the reaction, that is 60 seconds. This is the linear graph, analytical graph, and various concentration that we have since here through copper oxide particle with the oxalic acid. You can see here that the in blank, but when we add the concentration of 1 micromole, 8 micromole, up to 120 micromole, the graph was reduced and the absorbance and the intensity was reduced. This is the analytical graph, and we use this analytical graph to calculate the LOD and LOQ value, and you can see here that the LOD value of this copper oxide nanoparticle biosensor is 0.23 micromole, and LOQ is 0.78 micromole. You can also see here these are various type of interfering study, and we have checked that it produced best result only with the oxalic acid. These are various type of machine learning technique which we have used here. And you can see here that actually we use this machine learning technique in order to use uh, different expensive machine to quantify the level of oxalate. This is the metric comparison of all the machine learning models. These are the RGB value against oxalic acid concentration. And we have applied this sensor to sense the oxalic acid concentration in human urine also. And you can also see here that it detect various type of concentration in human urine. So this is the literature study, and we compare our finding with the previous already reported value. So our value is considerable and comparable, produce good results. We actually developed this methodology to sense the level of oxalic acid with low LOD and wide linear range. Therefore, the proposed sensor can be used as a good platform to sense oxalic acid and avoid the excess of oxalic acid in the human, and their on-time treatment and early detection of a kidney stone to avoid the later diagnosis and avoid the renal failure, because if it is diagnosis at later stage, uh, w- because it also, as I have already told, that the oxalic acid produce kidney stone. So if it is detect with the copper oxide at earlier stage, we can go through medical treatment and avoid late diagnosis and avoid the renal failure. Thank you so much for the presentation, and these are the references.